This conference will now be recorded.
Very good evening, students. Welcome to the PYQ discussions. We have been discussing problems from JEE Mains paper 2021, 27th July shift 1. So today I have picked up the questions from the 12th portion. So let us start our discussions. Let us read the problem first and try to solve it. The question says, two identical tennis balls, each having mass m and charge q, are suspended from a fixed point by threads of length L. What is the equilibrium separation when each thread makes a small angle theta with the vertical? This is very common question and also very interesting to solve, and it is the question from electrostatics. Let us see this figure. Look this figure over here. So two identical tennis balls. So these are tennis balls, each having mass m and charge q. So you might be agreeing with me that whenever there are identical charges, they will be actually experiencing repulsive force, right, due to the electrostatic interaction. Okay, so see, if I write this as electric force Fe on this particular charge given by this one, okay, so that's how they will actually maintain a certain separation x, okay, because they will repel each other. Another point is that, see, this is the thread of length L, and these tennis balls, they have their own weight also, that will directly act in the vertical direction, vertically downward direction, right? So we can see two forces acting on these two particles, and another force is the tension that acts along the string or this thread, right? So there are three forces acting on this tennis ball. So if we consider a single tennis ball and see the ABD for each sphere or spherical tennis balls, look, the ABD looks like this. I hope you are understanding. If you just draw a line over here, just along this weight, so this angle I can say theta, right? And the tension will be acting along this way, T, okay, towards the fixed point over here. So this is T, this angle is theta, okay. So I can break this tension in the thread into two components. One is T cos theta, another one is T sin theta, okay. So T sin theta along this direction, as you see, this direction, okay, this is T sin theta and this is T cos theta, okay. And look here, actually this is, see, we have to find out what is the equilibrium separation when each thread makes a small angle theta with the vertical. So this angle, see, each thread is making angle theta with the vertical, and at this situation it is in equilibrium. Equilibrium means there will be no net force. Equilibrium means no, so equilibrium implies no net force, okay. That means all the forces acting on each of these tennis ball will be actually counteracted by some other force, okay. Let me take one ball as I was showing you the FBD. Look here. So this mg, the weight of the tennis ball, will be counteracted by t cos theta. So t cos theta is equal to mg. I can write that. And what about this electric force? Electric force will be actually counteracted by t sine theta. See t sine theta along this way, and this electric force Fe or Af here. So that is in the leftwards. So I can write t sine theta equal to Fe, electric force between them. So what is Fe? What is Fe? Fe will be, see, I'll write K Q square, because Q1 Q2, right? Q square by X square. Okay, this is the force, and K is constant. C, that is 1 by 4 pi epsilon naught. All right, this is a constant. Now let us put this electric force and do the necessary calculations to find out X. So look, we have got T cos theta. Cos theta is equal to mg, and T sin theta is equal to Q square by 4 pi epsilon naught X square, right? So now we can just divide equation number 2 by equation number 1. Okay, that means I'm doing this. Okay, doing this, what we'll get? We'll get tan theta, and that is equal to Q square by 4 pi epsilon naught mg into X square, right? Because this divided by this. All right, so I have got this. Now what is tan theta? See, we have got, so we had got this thing. This is theta, right? This is theta. Look over here. If I just draw this figure, see, I'll just draw this. So this is actually the perpendicular bisector, the middle point, right? This one. See, perpendicular bisector, this one. This is 90 degree. You can see that. Okay. So this is 90 degree. So I can treat, see, I have a triangle like this, a perpendicular, sorry, so orthogonal triangle. So this has length x by 2, this is L, and see, this is theta. Okay, you can take this as perpendicular, this as base. So we have to actually find out what is tan theta. What is tan theta? Tan theta is perpendicular by base. See, in the options you don't have theta, right? I have to get the theta in terms of L. Okay, so what is this tan theta? Tan theta is perpendicular by this base. So what is this base? Let us find out what is base. Base will be actually, see, this one, if I say this is y, so y is actually square root of L square minus x square by 2, x square by 4. Okay, so this is fine. Just let me check once again what we can do. Actually, we will go with one more one more intuition. See here, the angle is said to be small angle. We'll just go with that. Okay. Then in that case, actually, we can write sine tan theta is equal to nearly is equal to sine theta. Okay. So I can actually write tan theta nearly equal to sine theta. So with that, we will go actually. Okay. That will help me to get the answer easily. Right. Otherwise, there also I have to make a lot of assumption as I have to find out this y. That will actually take you through a long calculation. Better to use this idea. Okay. So sine theta will be, so this is base, this is perpendicular by, so sine theta means perpendicular by hypotenuse. Okay. So perpendicular is actually x by 2 and that is L, so x by 2L. Okay. See why I'm not going with this tan theta is called perpendicular by base actually. Okay. Base I have to find out, that is going to be complicated. So better to go with this assumption since the angle theta is very, very small. Small angle. It is said in the problem. So that's why I'm not going with this. Okay. This is actually for small angle. All right. So now we can put this here. Tan theta, in place of tan theta, we'll write this x by 2L. X by 2L. Okay. All right. So if we put that, then see what we get. We get here q square by 4 pi epsilon naught mg x square. So these are all there. So this x I'll multiply here. So it will be x cube is equal to q square L divided by 2 pi epsilon naught m into g, right? So this is what we get. Then what will be x? So x will be is equal to cubed root of this quantity, right? So that is q square L divided by 2 pi epsilon naught mg whole to the power 1/3. So this is actually the equilibrium separation. So guys, you can understand how to do this or how to solve this problem. So first of all, you have to see all the forces over here acting on each of the tennis ball, and then you have to carefully draw the free body diagram. After drawing that, you have to actually see how each forces are going to be balanced. Okay, then only you will actually reach equilibrium situation. Okay, when there will be no force. Okay, no net force. Okay, so you can see from here we have got this answer. Okay, this x is equal to q square L divided by 2 pi epsilon naught mg whole to the power 1/3. Okay, so this is the answer. See, all other you have this option, half. Okay, which is not true. All right, let us go to the next problem. This problem is very interesting. See, this is from electricity, current electricity chapter. Here the problem says in the given figure, a battery of EMF E, this one, this is DC battery, is connected across a conductor PQ of length L. So conductor has got length L and different area of cross section, but the area of cross section actually varies. Okay, area of cross section varies. You can see that the radii actually changes. If this is a cylindrical one, so this, so as you go from P to Q, it is becoming narrower. Okay, that means the area of cross section varies. Okay, varies, having radii R1 and R2. See, this was actually R2, so R2 is actually less than R1. So this is the question. Now you have to find out uh, or choose the correct options. No, only one option. So one option will be correct. Choose the correct option as one moves from P to Q. So as you go from P to Q, which among these four options will be correct? First option says electron current decreases. Is that true? Electron current decreases. Electron current decreases. Is that true? Okay, let us see other options. Electric field decreases. Is this also true or false? Drift velocity of the electron increases. So the last option says it is all of these. All of these are correct. Okay, we have to see one thing here. See, as far as this first option is concerned, this is not going to be correct. You know why? Just because of conservation of charges. Just because of conservation of charge, this will not be true, because we know as many charges will be entering here, those must come out of this conductor. So the current of electron decreases. This is not true. So actually the battery will actually decide, just by seeing this, it will decide how many electron to be sent or how much current to be sent through this, such that there will be no logging of electrons. Okay, no logging of electrons. So electrons, whatever enters, that should pass through. Okay, so this is from charge conservation, we can say that. See, n number of charges enters here, n number of charges should pass through this also. Okay, all right, so then rest of the things are these two. So this is not true. Since this is not true, the first one is not, first option is not true, then I can strike out this option D. So I have to check these two, whether electric field decreases and whether the velocity of electron increases, drift velocity of electrons. In fact, these two are interrelated to each other. If we get this, say, we know that drift velocity is given by E into E by M into tau. Okay, so tau is the relaxation time, is the charge of magnitude of the charge of the electron, and is the electric field across the conductor. Okay, so if electric field decreases, then this one will not increase, drift velocity will not increase. Okay, or vice versa. So we have to now check what is the electric field, so like how electric field changes through this, whether the electric field changes at all with the area of cross section. So dear students, we know R is equal to, resistance is equal to rho L by A, right? So for this particular conductor, what we can write, since this, uh, let us say, let us consider one situation. Let us consider this figure. Here, I am just considering a particular portion where radius of this conductor is r and thickness has got some value, some dx. Okay, dx, or I can write dr also. Let me write dr itself. Okay, this strip has got a length dr. Okay, so for this particular strip, okay, or this particular disc, I can say this because this is cylindrical one, so I can take a disc. Okay, this particular, so the radius of the disc actually is decreasing as you go from P to Q, right? So that's why I'm just taking at any arbitrary disc of radius small r. So as we know, the resistance of this disc will be written as dr is equal to, rho is constant anyway, rho L I am writing as dr, okay, and divided by pi r square. This is the area, rho L by A, as I had written here, r is equal to rho L by A, right? So from here I'm writing the resistance of this particular strip. Then I can actually integrate to get everywhere. So as you do generally. So let me just uh, write this thing, this dr as, see, the current will be constant through the conductor, isn't it? Current will flow as it is. I hope you have understood this, that the current will not change at all. Okay, so but you know, this electric field may change. Okay, so I can write this at any time. See, we know V is equal to IR, so R will be V by I. Current anyway will be constant throughout the circuit, so I can write this as dV by I. Okay, I hope you agree with me. If not, just think it. It is true of what is written. So I can write this, okay? dr means dV, because the current is not changing, but see, the since this dr, the resistance is changing due to cross section, so something should be changing, otherwise this resistance will not change, and that is the potential I'm taking here. Okay, since the current is not going to change everywhere, current will be the constant. Now look what I'm writing here. See, dV dr, I have, see, I can write this, see, in terms of this also. So dV dr, just take magnitude, okay? Then I can write this as I rho by pi r square, right? And this is nothing but what? dV dr is, if I take magnitude, dV dr E is equal to dV dr. So what I can say from here? I can say that electric field is inversely proportional to r square. Okay, inversely proportional to r square. So when I have this kind of tube or conductor, here see, this is R2 here somewhere, so this is R2 say, and this is R1. Cross sectional area will be actually less here. As you go from P to Q, cross sectional area is going to change. So the electric field actually increases. So electric field increases as we go from P to Q, and we know Vd will be is equal to E charge into the electric field divided by M into tau. That means this is directly proportional to the electric field. Okay, so drift velocity Vd will actually increase and electric field also will increase. So these two options C we can cover from the same argument, that electric field decreases. This argument, this is not true. Electric field will increase and hence the drift velocity of the electron also will increase. Okay, so option C will be the correct answer for this question. Now let us go to the next problem. So this problem says a capacitor of capacitance C is equal to 1 microfarad is suddenly connected to a battery of 100 volt, as you see here. Okay, so this is a battery of 100 volt. This is CR circuit, CR series circuit. Through a, okay, so a capacitor of capacitance 1 microfarad is suddenly connected to a battery of 100 volt through a resistance 100 ohm. The time taken for the capacitor to be charged or to be get, okay, to be charged to get 50 volt. Okay, 50 volt. Here you have to take ln2 is equal to 0.69. This we know from nuclear physics also, right? All right, so here you have to find out the time that the capacitor takes to be charged up to 50 volt. So if you charge this capacitor slowly, it will actually accumulate charges, and the increase of charge or accumulation of charge or charging equation for a capacitor through resistor will be written in this way: Q is equal to Q0 e to the power, sorry, Q is equal to Q0 into 1 minus e to the power minus lambda, sorry, not lambda, e to the power T tau or T by CR, T by CR. So this is actually the equation of charging, equation of charging with time actually. Okay, how charge varies in the capacitor in with time as you connect the battery through a resistor R. Okay, resistor of resistance R. See here you have been asked to find out the voltage. When the voltage, so what is this? This when time is infinite, that means the steady state charge or the total charge stored in the capacitor when it becomes fully charged, right? And Q is the charge at any instant of time t. Okay, all right. So you have been asked to find out the potential when, sorry, when the, yeah, when the capacitor will be charged to 50 volt. That means this equation you have to write in terms of voltage. So we know Q is equal to CV, right? C into V. That means they will be actually proportional, isn't it? So equation, I can write the equation of the voltage or the potential difference across the plates of this capacitor with time as this way. See, V is equal to V0 whole into 1 minus e to the power T by CR. Why? Because this charge, see, just multiply C, then you get charge, right? C is anyway not going to change with time, so I can write this equation in this fashion also. What is this V0? V0 is actually the potential of the battery. Okay, after getting fully charged, the capacitor will have potential difference across its plates is V0, that is nothing but 100 volt here. That is 100 volt here. So V0 is 100 volt, and see the question says when this V instantaneous voltage, this V at any instant V becomes 50 volt, and V0 you know this is 100 volt, then what is that time when this will be V will be 50 volt. This is very easy. Let us just write once again here. V is equal to V0 1 minus e to the power minus t by CR. Okay, now this V is 100, this is 50, so 50 by 100 is equal to this term. So this will be half, right? So I can write, see, e to the power minus t by CR is equal to 1 minus half. Okay, that means half. So now let us take antilog or ln of this term. If you take ln of this term, what you get? Ln of this term, this will be then minus t by CR. Okay, and on the other side you take ln half, right? So this minus I have to actually remove, so I can write t is equal to minus CR ln half. So this minus you can just bring it here minus 1. Okay, so that you get CR into ln2. Okay, CR into ln2. So T will be CR into ln2. Now what is C? C is 1 microfarad, 10 to the power minus 6. What is R? R is 100. Okay, CR, and ln2 is 0.96. If we multiply all this, what we'll get? We'll get 0.69 into 10 to the power minus 4 second itself. Okay, look here, this will cancel, so this will be 10 to the power minus 4, this. So I'll get t, the time, when the time is 0.69 into 10 to the power minus 4 second, then the voltage will be 50 volt across the capacitor. Okay, or the potential difference across the plates of the capacitor will be 50 volt at this time. Okay, 0.69 into 10 to the power minus 4 second. So I hope you knew this charging equation. Okay, so this is very important. CR circuit and LR circuit, these are very important. So dear students, you must be remembering this formula. Okay, or this, yeah, so you can see this is for the charging. So discharging, we have to write Q is equal to Q0 e to the power minus T by CR, and this CR is actually called tau, like denoted by tau, and this is called time constant. Sometime you might be asked to find out what is time constant. Instead of finding t, they may ask to find out time constant. So that time you have to remember time constant means t into CR. Okay, t into CR. All right, so in that case the time t will be given. All right, so we'll move on to the next problem. Okay, this is again a very interesting problem. Let us try to read this problem and understand what is this problem saying. The problem is saying that in the reported figure, a capacitor is formed by placing a compound dielectric between the plates of parallel plate capacitor. The expression for the capacity of the said capacitor. So expressions are given. See first option, that is 15 by 34 into K epsilon naught A by D. Second option, 15 by 6 K epsilon naught A by D. Option C, 25 by 6 K epsilon naught A by D. And option D, it is 9 by 6 K epsilon naught A by D. So these are the options. You have to find out the correct one. See here, you can see that this is filled with dielectric material K and with the thickness D, and it will act as a capacitor of capacitance C1. Okay. Similarly, the second part you see of thickness 2D, it will act as another capacitor of capacitance C2. Finally, this will act as another capacitor of capacitance C3. So first of all, let us find out what are C1, C2 and C3. C1 I can directly write as K epsilon naught A. See, all of them have got the same area. Okay, you can see that area of the plates are same. Divided by thickness is different, divided by T. What is C2? C2 has got a value of capacitance. This is 3K, so I'll write 3K epsilon naught A, area is same, but this separation is not same, 2D. C3, this is 5K epsilon naught A by 3D. Okay, so all three we have got. Now you have to see, we have to actually get the combination of this capacitance. Okay, but what type of combination you see here? See, I can have parallel combination or series combination. Okay, or series combination. So in case of parallel combination, potential difference across each will be the same in case of parallel combination. Okay, but in case of series combination, potential difference across each capacitor will be different. Now look what type of combination we are getting here. Can you say the potential difference between these two plates is same as the potential difference between these two plates? Answer is no. Then what type of combination is this? This is actually series combination, C1, C2 and C3. So in case of series combination, what we get? 1 by C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So this is the typical part where students may do mistake. Okay, in case of parallel combination, you know what we do. So suppose you have been given different dielectric material to insert inside that, like this. See, their area of cross section is not same, but this distance is same actually. Okay, within the same distance. Okay, so this is where is the difference. Okay, so this will give you parallel. Okay, this will give you parallel combination. Okay, this one, this will give you parallel combination, but in this case it is series combination. Now let us Let us calculate the equivalent capacitance. Okay, so first one, let me take this common, k epsilon naught A by D. Look here, first one will be 1, right? And second one will be 3 by 2, and third one will be, okay, sorry, this will be D by that. Okay, I'm sorry. So D by that, 1 over C means D by that. So 3 by 5, the last one, and I have to add 2 by 3 and 1. Okay, so there will be little change here. This is D by K epsilon naught A. This is common. Now this is plus 1, and then it is 2 by 3. Yes, 2 by 3, then 3 by 5. 3 by 5. So I have to do the LCM, nothing else. So this term is common. So I get 15, 15 here. So 10 here, and here 9. So what we get? See, this will be 34 D by 15 K epsilon naught A, right? Now if we take reciprocal, then C equivalent will be 15 K epsilon naught A by 34 D. Let us see whether this option is available. Yes. So the first option, see, we have got 15 K epsilon naught A divided by 34 D, and see here I have got the same here. Okay, so the option A will be the correct answer for this question. All right, so we'll move on to the next problem. Okay, so this is also from capacitor. So this question says two capacitors of capacitance 2C and C are joined in parallel and charged up to potential V. That means, you know, there are two capacitors joined parallel and then charged with a battery. Okay, V. They are fully charged. When they are fully charged, they will have potential V across each of them. Suppose this is C and this is capacitance 2C. Right? The battery is removed and the capacitor of capacitance C is filled completely with a medium of dielectric constant K. The potential difference across the capacitor will be. See, the question is saying that after charging up to V volt, this battery is removed. Now they are fully charged. Okay, fully charged. At this situation, if a dielectric material is filled with within this actually filled in this gap between the plates of the capacitor of capacitance C. So this is a dielectric constant K. Then what will be the common potential difference at this condition? Because they are connected, so there will be common potential difference. Okay. So let me give you the options given here. So options are number 1, 3V by K. Option B is V by K. Option C is V by K plus 2. And option D is 3V by k plus 2. Okay, so these are the options. You have to find out which one is correct. So dear students, here, for this kind of combination and all, what we do, we see when the external battery is removed, then what is going to be constant here is the charge. Total charge remains constant, whatever it may be. Total charge will be constant. Okay, so what is the charge? When they are charged, before inserting this dielectric material into this capacitance capacitance C, then what was the charge? Total charge was 2CV plus C into V, that means 3CV. Okay, this much charge was there when it is fully charged. Now after this medium has been inserted, the capacitance of this capacitor C has got changed. Okay, this capacitance has been changed, but the total charge remains the same. With this, let me find out what is the new capacitance. So new capacitance C prime is actually, see, this capacitance C 2C is there already, plus C prime. So that is actually K into C. Okay, K into C. That means, this is K plus 2 into C. This is the new capacitance. Okay, new capacitance in combination. Okay, now what will be the potential then? The charge is same, right? Q will be actually C prime into V common, or V prime, let us say V prime. We have to find out the potential. So the charge will be same, 3CV is equal to C prime V prime. Then from here I will be able to find out V prime, because I know what is C prime. Okay, so this is 3CV divided by C prime is K plus 2 into C. This C I can strike out. So what I get, V prime is equal to 3V divided by K plus 2. Okay, so what I get, V prime is 3V divided by K plus 2. So this is the new potential difference across the capacitors. So option D will be correct answer for this question. Okay, so this was very simple. You have to just apply the conservation of charge here. Okay, or the total charge remains constant, that concept. Okay, so I think I have got another problem. With that, we'll conclude today's session. Yeah, so this is very interesting problem. Let us try to solve this. If F denotes the ratio of the number of nuclei decayed to the number of nuclei at t is equal to 0, that is n0, then for a collection of radioactive nuclei, for a collection of radioactive nuclei, the rate of change of this F with respect to time is given as, the options are given here as minus lambda whole into 1 minus e to the power minus lambda into t, where lambda is actually the decay constant, as you know. This is lambda into 1 minus lambda t. Option C says it is lambda into e to the power minus lambda t, then minus lambda e to the power minus of lambda t. So this problem is very simple if you can understand the language of the problem. See this ND, the problem is saying that F is ND by NO, okay, or N0. This is at, so this is the initial step, okay, initial number of nuclei when time is 0. But what is this ND? ND is the decay number of nuclei which has been already decayed. Excuse me. So how do we find out that? So initially there was N0. Let us say at any sort of time it has become N. Okay. So this is N of T. So this is actually ND. This is N0. Excuse me. Now what is N of T, that you know, right? N of T is N0 e to the power minus of lambda into T. That we'll put it here. Okay. Let me clean this. This N of T is the number of nuclei present in the sample, radioactive sample, after time T. So that we have written N0 e to the power minus of lambda into T divided by N0 here in the down. Okay. So now we get 1 minus e to the power minus of lambda T. So this is actually the ratio. Now you have to find out what is the time rate of change of this. That means you have to find out the time derivative of this F. So that will give you lambda into e to the power minus of lambda T. So this is the answer. Okay, so option number C will be the correct answer for this question. As I said, this is very simple problem if you don't do this mistake. Okay, if you understand this point, then the problem is very easy. Okay, do I have any problem more? No. So with this I'll actually stop it here. Next day we'll take up problems from 11th portion again from the same paper if some problems are still remaining. Okay, so thank you for your patience. Bye for today.